Welcome back, everybody, to October's AMA. Ruben, it's going to be an amazing time tonight. Lots of amazing things happening at the DC 1, 2, and 3. We're going to see a full program update from across the board. Just looking at the chat here, again, as always, we have people from all over the world connecting. On average, we have more than 2,000 people connecting to each one of these AMAs. It's really incredible to see how this network is really growing worldwide for the interest for the HX50. Action-packed evening tonight for everybody here. Ruben, why don't you tell us what we're in for?
That's right. One more and getting very close to the finish line of that first aircraft. Going to be seen on stage on the 6th of December. And today's program is going to be, as usual, an update of very rich and packed information from Jason for about an hour or so, probably a little bit less. And then we're going to enter the AMA, which is something unique of the Hill program. We open up for questions from anybody. You can ask anything. We put them in sequence. So start putting those questions as the presentation goes, and we'll go one by one at the end, right after the update that we will be hearing from Jason. So with no further delay, let's then give it all the time for Jason. Welcome, Jason. Go ahead, and you can start your one more wonderful update.
Thanks, Ruben. Thanks, Misha, and welcome to everybody from around the world this evening to DC1. We've got a packed program for you this evening, covering the airframe, the engine, the drivetrain, avionics, electrical systems, and an update from across the production facility and our plans for our growing production facility into series production. Let's start with an update on the build of fuselage 6 and 7. As I explained last time, these are fuselages that are very much a culmination of everything that we've developed in the program to date. All of the improvements and enhancements that we've developed to the manufacturability, the processes and the core design are embedded into both of these fuselages. They include the brow line modification for improved view angle. They include the exterior lighting integration for our developed lighting clusters. They include the carbon fiber bulkhead integration and all of the mechanical components that need to be embedded in the fuselages to receive the undercarriage systems and of course the cabin door systems. In addition to that, we've been working through the development of the first two structurally representative tail booms. So these are tail booms that include all of the features that they need to attach structurally to the monolage, all of the features to attach the drivetrain and all of the mechanical components, and a representative laminate as well. So all of those things are in there, and we'll be heading down to DC2 to have a look at these in just a second. We've also been extensively developing the new versions of all of the cabin doors. So these are the cabin doors that use the bonded assembly, so both a tooled exterior skin, a tooled interior skin, trapping all of the door furniture and bringing those together in a much more production orientated process. I'll be giving you a significant update on those directly from DC2. So without just looking at slides, let's head down to DC2 and DC3 now, and I'll show you what we've been doing over the course of the last month or so. So welcome to DC2, and at the moment down here it's doors, doors, doors. The guys are furiously laminating the doors for the front of the fuselage, the rear of the fuselage, and the cargo doors. There's 12 to do in total for the two airframes that we're building at the moment. Let's go and have a look at what they're actually building. So our method for producing doors, as we've discussed, is two tooled skins, so an outer skin and then an inner B-surface skin that carries all of the detail for the locking mechanism and the internal trim door card. We work on model board tools at the moment. What you can see the guys doing here, this is the front co-pilot's door outer skin. So the first plies are down. We're just putting in the receiver for the swandle handles here. There'll be plies laminated over the top of that, and then this can be bagged and cured in the oven. This is an out of autoclave pre-preg system that we're using for these particular parts to make it easier to get the metallic inserts in. If we move over to this station over here, we've got a similar operation here, but this time it's a rear passenger side door. The first plies are down, the door handles metallics are in there, and the guys are just laminating over the top to trap and bond the metallic inserts into the fabric of the door. Again, You can see the modification that we've introduced here, where we've built in the notch to receive the signature lighting strip that we've got built into each of these doors. There's a further pilot's door skin here, so this is a front door, pilot's door, outer door skin. That's being laminated and that should be ready for curing later on tomorrow. If we go down here, you can see the B surface, not the B surface, the internal skin of the baggage bay door. So you can see the internal skins tend to be much more intricate because these are the skins that form the depth of the structural sections that give the door its stiffness and provide the pockets for the hinges and the locking mechanism and everything else that you need to make these doors work. So once these panels are cured off, they go into a glue jig, they're glued together, and then they can be trimmed and fitted to the airframe using the hinges and the other mechanical components that are being developed up at DC1. The only other things that we've got going on here at the moment is we've got another B surface here. This one's a little bit further on. It's under vacuum bag being debulked, ready to cure shortly. If we go and have a quick look what we've got going on in the oven, excuse the darkness. What we've got in here, we've just shown you the internal surfaces for the cargo doors. What you've got here is a left-hand and right-hand external skin for the cargo doors on both sides of the airframe. They're all bagged under vacuum and ready to cure. We get a full oven load of components in here this evening, and then this will be curing right now while I'm talking to you guys. Let's have a quick look at what's on the gantry mill. So as you can see here, we've also got other tools here waiting to be laminated. So we've got rear door B surfaces for port and starboard. We've got the rear cabin bulkhead, so that's your baggage bay bulkhead there. And then what we've got here, this is the co-pilot's door inner skin. So this is the last of the door tools that we need to make to be able to produce the final door for the HX50 fuselages. One thing you might notice is that the one side of the table on the gantry mill is inoperative at the moment. We're having more issues with this machine, and I'll talk about what we're going to do about that a little bit later in the presentation. Let's go over to DC3 and have a look at some fuselages. Welcome to DC3, and this is where things are getting really exciting. So we focus on laminating and component production over at DC2. Here in DC3, the guys are doing a lot of the gap and flush and fit and finish and working on the full airframe. This is airframe 6 that's just come back from its first layer of surface treatment and paint production. What you can see here is we've now got the updated brow line into this fuselage and fully worked in. The exterior has been prepped from a surface point of view, so it's ready to be painted. You'll also see with this one that a lot of the metallic elements of the structure that are required to mount the undercarriage are in there also. So you can see the undercarriage mounting pads down in the stub wings. You can see the receptacles for the undercarriage locking struts. And then we've also got all of the metallics up in the roof to pick up the gearbox, and then of course all of the metallics down in the tail boom to pick up the structural loads from the tail boom. The fuselage has been fully trimmed, so all of the apertures have been trimmed back to size. On these prototype airframes we're doing that by hand using the trim lines that we've built into the tools and patterns. In production this will be robot trimmed using a bigger version of our robot that we'll show you down at DC1 a little bit later. So in addition to this, the other things that we've been doing is essentially making sure that we've resolved all of the edges properly so that when we come to fit the doors that we've got nice clean gap and flush. Similarly, we've been tidying up the edges up for the glazing, where the glazing fits up on top as well. You'll notice here that we've got a test cabin baggage bay door skin here. So this is an outer skin. You saw the inner skins being produced over in DC2. That's been trimmed and is up there just to dress it and get it ready to be fitted with its B surface. You'll also see for the very first time that we've got the non-structural wing covers on the airframe as well. So you're all used to seeing the airframes, just the structural elements of the airframe, which is the painted part of it here. This is the wingtip cuff that makes up the rest of the A surface that you're used to seeing in the renders. And then this is the recess that provides for the landing light, or the wingtip element of the landing light, that I'll show you a little bit later on in the presentation. So really pleased with how all of this is coming on. It's looking absolutely great. The sort of fit and finish of these components has really exceeded my expectations, particularly given the challenges of working with very hastily produced prototype patterns and molds. But the guys have worked wonders on getting this all to sit together right. So I'm really excited to see the rest of this come together and to get it painted up and finished. In addition to the external fittings, so the wingtip covers, the doors, we've also got structural internal components. So this is the carbon rear cabin bulkhead. So this fits inside the fuselage at about this point here. This big aperture that's molded in it is physically so that we can get the bladder fuel tank into the cavity between the cabin rear bulkhead and the baggage bay bulkhead, and this fits snugly inside of there. It's been dry fitted, it fits just fine, which is good news. So we've got two of these waiting to go into the fuselages as we assemble them. That's all good. I showed you over the road that we're busy laminating doors. This is a B surface for one of the rear cabin doors. So again, it's an extremely light piece of structure, but all of this integrated form provides the structure that we need to carry the armrest loads and to pick up all the locking mechanism details as well. So really pleased with how the guys are getting on with the door skins. They're coming together very nicely. If we just go around and have a look on the other side of the fuselage for a moment, what you'll see is we've also just offered up the very first trimmed B surface. So this is the rear starboard side door, and that fits just nicely. So the overall form of it's fine. We've got to get that bonded up now. Well, skin pinned with its A surface. That'll take account of the pushback from the seals once we get those fitted, and then that door can be hung and will sit really nicely on the fuselage. So really pleased with how that's coming together. Let's go and have a look at what we're doing with tail booms. So this is the second structural tail boom that we've produced, and this is the one that's had the most prep work done on it to date. So as I mentioned earlier, all of these composite components that we're showing you at the moment have been manufactured with prototype tools that were very hastily put together. They were all about process development and not about getting the most perfect surface finish. So in order to get these paint ready, the guys have had to do a lot more patchwork, a lot more filling and sanding than you would do in production. What you can see here is the structural element of the tail boom. The tail boom cover that covers the drive shaft as it goes down into the tail boom. And what you'll see here for the very first time is the second side of the tail boom. So the construction of this whole structure is made in one piece, with the exception of this top closure on the exit side of the duct that allows us to trap all of the internal fixtures for the stator for the ducted fan assembly. So this panel has been trimmed and bonded on today, and then of course the final stage is to fit the bumper panel on the bottom. We've also made the modification down here to take the modified tail light, which I'll be showing you a little bit later in the presentation. If we just have a look at what we've got here, this is the second structural tail boom that will be going on fuselage 7. This is currently untrimmed. The guys are just starting to prep this for paint at the moment. But while we've got it here, you can see essentially the frangible or disposable bumper that sits on the bottom of the tail boom down there. So where you see the A surface breaking there, that's so that we can put an energy absorbing bumper to protect the tail assembly, and ultimately to protect the helicopter if you have a little indiscretion while you're trying to land. So from across the board down here, the guys are making fantastic progress on all of the composite elements of the program. We've got fuselage 7 out at paint at the moment, and then we've got a bunch more fitting to get the tails integrated, and then all we've really got left to make in terms of the composites are the last of the doors and the non-structural elements that sit on the top of the fuselage. So fantastic progress from across the program over the course of the last month. Let's head up back to DC1. So in addition to the work on the core fuselage, we've also been doing a lot of work on the first set of prototype skids that will be sitting on fuselage 7. So essentially these are skids that are structurally and kinematically representative of the skids that we'll use in the flying prototypes. The only difference being there's a little bit more weight to come out of these things before they're ready to go flying. We've come up with a very practical and cost-effective structural design, which is a hybrid of both a conventional metal tube structure that couples very nicely back to the dampers that we need in the fuselage with a cladding to deliver the sleek look of the skids. The metal tube structure is currently about halfway through being produced, and we've just finished the molds to be able to mold the composite cladding that goes around the legs and the down tubes. We've also been developing all of the mechanical components that are used at the top end of the skids to fit those back into the fuselage structure. And there's actually on the 5-axis over there the last of the receptor couplings that connect to the metallics that are buried into the structure. So really pleased to see those coming along. I know there's a lot of guys out there that are keen to see how we're doing with skids. So just a little update that they're coming and they're going to be ready for December. In addition to that, one of the things that is most distinctive about the HX50 is the cowled rotor system and the very carefully aerodynamically cowled pylon and mast. This is a particularly difficult area to do well because of the movement that you have to allow around the root of the rotor blades, and it's also really important that we deliver on the aesthetic promises of the design. I'm pleased to say that we've delivered this in spades. I'm absolutely over the moon with how this has come out in final design. The production tooling for all of this is currently underway at the moment. The guys are busily finishing the last of the tools to develop all of that cabin top structure, both the cowls that surround the engine and all of the plant and equipment that lives on the top of the fuselage, and also the donut cowling that surrounds the main rotor hub. We expect the part production of those to start in around 2 weeks' time, and those will be the last components that we need to make for the two machines that we'll be displaying in December. So really pleased to see all of that coming together. In addition to that, we've been talking at length over the last few months about our endeavours to deliver high optical clarity, high quality, crash-worthy windows, crash-worthy glazing for HX50. We've been doing a lot of development over the course of the last month or two to improve the quality of the tooling that we use to be able to deliver optical clarity. It's relatively easy to form these materials. It's quite difficult to form them really, really well, particularly when you move to polycarbonate for the impact resistant windows on the front. We've completed all of the rework to the tooling. That takes into account both the shift in the brow line, but also the surface rework that we've needed to do to deliver a surface that's capable of producing optically clear windows. We've optimized all of the forming processes necessary to deliver high quality windows, and then we've now started to produce the full batch of glazing that we're using for the two machines that we're delivering in December. So fundamentally, all of the roof windows and the side windows are now at a level that we're satisfied with for production. We've got a couple of issues left to sort on the chin windows, but fundamentally we're satisfied now that we can produce high quality glazing for the aircraft in-house. Let's go and have a look at a couple of the examples that we've got lying on the shop floor over here at DC1. So what you can see here is the first of the vacuum formed chin windows that's been developed using the latest tooling. So all of these areas here are excess material that will just be trimmed off, and the actual chin window, so this sits under the nose of the helicopter, is this portion here, and the trim line sits about an inch inside this. So these are now being produced to a quality that's sufficient from an optical and a performance point of view. There's a few things that we'll refine for series production, but these are plenty good enough for where we need to be at the moment. These are the most difficult windows on the whole aircraft to produce, because they have curvature in both directions, and it hugs the tool very closely. So until you're using heated aluminium tools that are highly polished, this poses real challenges for the composite tools and the model board tools that we're using at the moment to keep the costs down while we're going through the development process. What you can see behind me here is the forward roof window, and this one is a lot simpler to form to a high degree of optical clarity on account of the fact that it's a lot flatter and a lot simpler curvature. So we've got all of these produced now, and we're expecting to get these units trimmed over the course of the next week on the gantry mill, and then they can be dry fitted on the fuselage, ready for the rest of the panels to butt up to. So really pleased with how the glazing's coming on. One of the areas that we always knew was going to be challenging was painting these early fuselages. So as I've said on multiple occasions, the tooling that we developed for the early stage prototypes for HX50 was very much about bringing together all of the elements from different industries that were necessary to make cost-effective composites at this scale and in these volumes. What that has meant is that was very much an expedited process. It was all about the process development and not the finished surface quality. So the surface on the tools that we've been working with to date isn't at the same level that it will be in production. And what that means is, unfortunately, the paint guys have an even harder job to do to get a decent paint finish on these things for the first fuselages. So over the course of the last week, fuselage 6 has been out at the paint shop, and the guys have been doing all of the surface preparation and the priming and the surface rectification to get that fuselage up to the point where it's a high quality paintable surface, and they've done an amazing job. Now, don't worry about any of these details, because fundamentally all of this comes from the tools, and with the new gantry mill that will be arriving in January and the refined production processes for patterns and tools, all of these things come straight out of the mold for production. But over the course of the last week or so, fuselage 6 has had its several coats of primer and a lot of surface work, and fuselage 7 is out at the paint shop right now, getting ready to receive its final colour. So really pleased with how that's gone over the course of the week. Let's talk about the engine program for a little while. Over the course of the last month, as you're aware, our main focus has been about preparing to do the combustion system testing. So we finalised the design of the combustion, the core combustion test rig elements. All of those things are now either here or in production at the moment. We have essentially produced now all of the fuel nozzles and the air blast atomizers. We have the ignition system here. We've also been doing some further work on blade casting, and I've got some good news to report on that. And we've been starting the journey on the casting of the big thin-walled casings, which is one of the other challenging areas with the engine development. We're almost now we're now converging on the finished combustor, annular combustor itself, and I'll be showing you a little bit more of that in a second. So as I mentioned, a lot of the work over the course of the last month has been about refining the combustion test rig and getting all of the additional equipment you need beyond the engine hardware to run a successful test. The guys have been efforting that over the course of the last few weeks. The objectives, of course, being to show that we can get effective ignition, stable combustion within the environment, and get that fire burning. All of those components are now in manufacture, and these will all be here before the end of the month. One of the things that we are doing for the combustion test is using rapid prototyping as an analogy for the casting processes for the casings, just to give us the flexibility to change anything that we need to before we go on to the full-blown gas generator test. Everything else that you can see in the combustion test is being made right here at DC1. So if we talk for a second about the annular combustor, we've now perfected the rolling process. We've perfected the stretching process to produce these annular rings perfectly to tolerance, and we're now building up the stack of internal and external rings ready to get that welded together, and I shall show you that in just a second. We've had some issues with spinning the end cap, so if you think of the end of the donut on the annular combustor, and so the guys have been machining some of those components from solid rather than spinning those in the short instance. In production, those parts will actually be pressed, but I'm loath to lay down a press tool until we know we've got the geometry right. So Mark's been working around that for us, and I'll show you some of the components that we've been making in just a second. The other big news is that over the course of the last few weeks, we've been doing a lot of NDT and a lot of inspection on our in-house cast superalloy turbine blades for both the gas generator and also the power turbine. And I'm delighted to report that we have now concluded that work and we've passed all the inspection criteria. So Hill Helicopters can now cast inexpensive superalloy turbine blades in-house, and we're doing so ready for the test engine. So really pleased with that. The scanning electron microscope results were just what we were expecting. We've got a little bit of process optimization to do, which I'll show you in just a second, and then we're ready to invest in the casting infrastructure to enable us to do that in volume as we go into production. The final innovative step in the casting journey is to be able to cast the large casings that we need for both the engine and ultimately some of the aluminium casings we need for the aircraft gearboxes as well. The challenge with these casings is that they are extremely complicated, they're quite big, and they have very thin walls. And what that means is it's actually difficult to get the molten metal to flow through those cavities without solidifying too quickly and blocking the cavities before you've cast the part. So we've been developing with our casting partners some very clever processes to enable us to do that for the types of parts that we need. That work is ongoing at the moment, and we'll be traveling out to Germany over the course of the next month or so to finalize that step. Once we've finalized that step, that is literally the last part of process development that we need to do to make this engine. This isn't something that's holding us up for the prototype engine because, as I said, presently we're using rapid prototype parts for the casting, which is a perfectly representative process to do. So let's go and have a look at some of these details on the engine. So, as you're aware, we've been casting both power turbine blades and gas generator blades using trees. So part of the process development that we've been doing is looking at the different performance of block molding and shell molding, and we've now got specimens back from the test lab that are used both block molding and also shell molding. The benefit of block molding to us is that it's a substantially cheaper process. It's much faster to execute, and the equipment we need to do that is far less expensive. To facilitate all of that, we've been doing a lot of development in the process for making the wax trees that you need to be able to hang a load of these turbine blade waxes and create a cavity that allows you to create multiple turbine blades in a single shot. So we've produced some tooling that essentially allows us to cast a wax sprue onto which we can then weld the individual turbine blades, drop that into the block molding slurry, and then melt this out, and we've got our casting void. What you can see here is the very first Hill produced block molded gas generator turbine blades, and here we have the analysis report that shows that they can form geometrically, and then on top of that we also have the metallurgical report back now that shows that the metallurgy is right, the crystal structure is right, we're making good blades. These have now got to go off and be hot isostatically pressed to make sure we close off any voids, x-rayed, and then these can be ground and are ready to go into an engine. So really pleased with how that's coming together. We've also done the same for the process with shells so that we can compare the metallurgical properties and the mechanical properties to see if there's any advantage to us in sticking to the older ways. I don't expect that there will be for the turbine blades. I think the process gives us much more control doing it with this slightly more modern approach. So really pleased with how that's going. If we move on to the combustion system now, you've seen over the period of the last few months, we've been laser cutting and rolling and forming and profiling the rings to make up the annular combustor. And we've now got this process to a point where we're making these things to tolerance. And what you can see here is a couple of I've just pulled these off the work shelf over there. This is the size of your annular combustor. These are conforming outer rings, conforming inner rings. These get grown up to about this height, capped off. There's a bird mouth in the center that feeds into the gas generator turbine nozzle, and then we're good to go. And the way these things work, the reason why these profiles are so important is if you look at the subtle gap at the top here, the void that's created by this change in profile, that's the area that when we drill holes on the back of this lip, feeds cooling air down both the outside and the inside of these thin sheet metal pieces to be able to put a blanket of cooling compressor delivery air over the metal to keep the metal temperatures down to a level that they can survive. So the geometry of that is really, really important. It's fiddly stuff to do, and we've cracked it. So the first combustor is well on its way to being completed now, and as we get to the end of the month, this thing will be built up and welded, ready to go into the test rig. If we just have a look at some of the other components that we've been producing, that component that sits around the end of this combustor can will actually be pressed. There'll be a sort of donut annular tool. Thump, you press it out of sheet metal and away you go. Quite simple. Those press tools are quite expensive for this sort of material, so what we've been doing is trying to spin those, which hasn't really worked very well. So we've made a simple tool, and then Mark and the guys have just been essentially making some machined inserts that can be welded in that will receive the air blast atomizer. So what you've got there is the swirler nozzle. So that's the back face of the combustor here. The swirler nozzle goes through there, and inside that swirler nozzle we have a fuel injector with integrated last chance filter. That sits just inside that assembly there, and what you've got here is a small fuel nozzle, and out of this void comes swirling air that smashes the atomized fuel into tiny particles that give you nice clean combustion, which is both highly efficient and minimizes the amount of sooting that we get in the engine and ultimately down your tail boom. So really pleased with how that's coming on. And then the other piece of the puzzle that's dropped in recently is we've taken delivery of the first few igniters that fit in the bottom of the combustion chamber to get the fire started. So really pleased with how the combustion rig's coming together. And like I say, we should have all of these bits on hand and ready to assemble within this month. So we'll get that test done just as soon as we can. Let's head back. So let's talk about the drivetrain and gearbox production for a second. So as you're aware, we built the first HX50 gearbox about 12-18 months ago as essentially a lubrication test rig, proving that we could get lubrication into the bearings and the oils to drive the gearbox at the powers that we want to have the life that we want to, and to ensure that the gearbox can run dry as required by the certification requirements. Since that gearbox was built, we've made a bunch of modifications to the gear design, to the lubrication strategy, and also to the mast design. So what we're doing at the moment, we've got that gearbox stripped, and we're fitting the new mast with the rotor hub assembly on the top of it into the gearbox. And we're also producing new casings for the 2 additional gearboxes that we're producing for the 2 aircraft to be displayed in December. So really pleased with how that's coming on. Let's just go over and I'll show you some of the bits that we're producing right at the moment. So what you can see here is these are some of the strip components from the original gearbox. This is the new Sprag clutch that I showed you a month or so ago. You've got your planetary set and your spiral bevel set that is the first stage into the gearbox. And here is the very first second generation rotor mast for HX50. So this has got the latest spline detail, the latest connection detail to get the rotor mast connected into the transmission, and all of this new stuff that you can see at the top is the very first components that we've produced for the HX50 rotor system. So you've got the upper and lower clamping plates that are splined onto the main rotor shaft, and just so that you can understand where it goes, essentially they clamp the strap packs that provide your flapping and also your feathering motion for the rotor system. So all of that's coming together very nicely. What you can see down here on the bench is we've essentially got the upper casings for 3 additional gearboxes that we're producing at the moment. We're part way through machining the planet carriers for 2 of those gearboxes, and we've got the remaining 2 rotor masts there just waiting for the final couple of operations to receive the rotor head on top. So really pleased with what the guys are doing on transmissions. That's all coming together very nicely just in the nick of time. So one of the things that's been particularly exciting over the last couple of weeks is that we're now deep into building the very first HX50 rotor system. The upper and lower hub parts have been produced, as I've just shown you over on the bench. These are the components being machined on the 5-axis, and we've currently just finished this afternoon the very first HX50 blade cuff. So this is the part that receives the composite rotor blade. It houses the elastomeric lag damper. It connects to the strap pack that facilitates all the blade motions. It's aerodynamically designed, and it also connects to all of your blade fold features as well. So we're really pleased with how these have come out. Let's go and have a look at that on the 5-axis so you can have a look at what we've been doing to deliver these key components. So this is the second 5-axis machine that we added recently, and here is the very first HX50 blade cuff number 1. So this is a part of the blade, so that the rotor blade root connects here, the lag damper lives inside here, the strap pack lives in here, your pitch control rods or your rod ends attach on this lug down at the bottom here, and then the aerodynamic cowling that works into the rotor system fits up against these components here. So that's the very first one that we've ever produced, and what you can see right here is the next 8 that have had their internal machining ops done, that are just waiting for their turn on the 5-axis to be turned into rotor components. So really pleased with how that's coming. Let's talk for a second about the swash plate assembly. So some more fun stuff. One of the other things that we've been building recently is the swash plate assembly and all of the flight controls that sit just below the rotor hub. So what you can see in that inset figure there is the strap packs at the top, and then you've got your rotating and non-rotating swash plates, your spherical bearing in the center, and your pitch, roll and collective jack rods, jack beams, sorry, that are mounted on top of the main rotor gearbox. All of those components have now been completed, and they're sat on Craig's bench awaiting build. So let's just go and have a quick look at the build of the very first, well, not the very first actually, the first 3 HX50 swash plate assemblies. So what you can see here is the assembly drawings for the whole system. So you've got the spherical bearing, the swash plate assembly, and all of the detail that the guys build to over here. You've got the collective jack beam. So this is the beam that lifts the whole swash plate system up and provides collective pitch. And then you've got the pitch and roll jack beams as well. So your cyclic is connected to these 2, and your collective is connected to this fellow. And then over here, we've got the first 3 swash plate assemblies. So fixed swash plate assembly at the bottom, and then the rotating assembly at the top. And the only thing that we're waiting for at the moment is this fellow that I did show in one of the customer updates, that we've actually machined these. They've all been made, but they're out at the moment being anodized and then PTFE coated, so that we've got the lubrication for the spherical bearing. And then those 3 assemblies, 2 for the aircraft and 1 for a static test rig, have been built. And then what you can see here is it's yet to be completed, but the mechanical and the part of the elastomeric part of the lag damper that's buried inside the blade cuff. So really excited to see this stuff coming together. It's a really exciting time to be around here at DC1. So one of the areas that we talked extensively about in the early days, but we haven't talked about much since, is our ducted fan tail rotor. So we're designing the tail rotor on HX50 to have a great deal of authority, even up at hot and high altitudes. We've got 8 asymmetrically spaced blades, a very deep duct, and then linearized characteristics through the way that we've done the control rigging. We've updated the aerodynamic design. The aerodynamic design was done a long time ago, but it had been a little while before we could get capacity onto it to get the mechanical design updated in the aircraft. That's now done in terms of the blades, the pitch change mechanism, and the overall housings and blade retention. We've got a little bit of work to do left on the gearbox, but essentially that's now updated and also being produced right now at the moment. What the guys are doing down at DC2, and you could see it in the images I showed you during the walk around, you can see it on that slide there, is we've developed all of the tooling and the jigging necessary to be able to drill off and provide the fixtures for the stator into tail booms 2 and 3 that are down there at the moment. So the guys are providing all the provisions at the moment to get that tail assembly into the duct of the 2 aircraft. So really pleased with how that's going on. The performance of the tail rotor is incredible. We still maintain directional control with 35 knots of wind from any direction, even up at 10,000 feet. So barring any nasty surprises on test, we should have an awesomely powerful tail rotor. And the only thing we've really got left to do on that is a minor gearbox tweak, which will be picked up early in the new year. So really pleased to see the tail rotor coming together. The other thing that's gone on over the course of the last week is, obviously, as we get closer to flight test and we get deeper into our approvals process, we're having increasingly regular meetings and engagement with the regulators. Over the course of the last week, we've had a very successful visit from the engine and transmission specialist at the CAA. We've been going through our test and certification strategy and some of the detailed elements of the test and certification plan for the engine and the drivetrain elements, because all of those elements are going to be the first things that we need to do in order to make sure that we've got enough hours on those things on the bench to be able to safely de-risk the flight testing. So the meeting went extremely well. The guys were very impressed with where we're up to and what we've got done. And our new lead of engine and transmission certification performed extremely well. So we're in safe hands. The approvals process is going as well as can be hoped for where we are in the program. So really pleased with that. The guys were also delighted with the capability that we've developed here at DC1 for bearings, gears, and the other critical components in the engine and drivetrain. So a very successful visit, full stop. Let's talk about the DigiCockpit for a second. I teased a little bit last month that we've been doing a lot of work on the IPI. We've now developed through a great deal of detail on the IPI. So this is the integrated pilot interface that distills the big stack of black boxes you've got in the center of your cockpit into one single 7-inch screen. The user interface development of that has been refined and optimized now. The menu structure for that has been developed, and Eric is busily implementing that into the software environment ready to be loaded on board the aircraft. We've got a much simpler menu structure, a nice simple home page with a very shallow structure. It's much easier to interact with the puck, it's a cleaner look, and then we've got an accessible toolbar at the bottom that gives you one-click access to pretty much anything that you could want to do with the IPI. It's still very much work in progress, as these things often are, but you'll get to play with this at the event in December and make your own mind up whether we've done a good job or not. I think the guys have done an incredible job myself. We've also been doing some more work on the MFD. So this is the second screen on the co-pilot side of the aircraft. You've obviously got video feeds available to you on that screen. You can have a duplicate set of flight instruments on that screen. But one of the things that we're developing for that screen at the moment is a user interface that's much more usable by a non-flying customer, and also a very large traffic scope. So these are very much work in progress ideas at the moment. So if any of the customers have got any thoughts or ideas about that, please do feed it back. But in that particular setup on the screen that we've got there, we've got salient information at the top for non-flying passengers. You've got a big cover flow media center on the left-hand side, and a big traffic scope available to the pilot, nice, big and bold. So again, work in progress, but we're pleased with how that's coming. And don't forget, we'll be feeding video images as a background to that as well. One of the other areas that's really taking shape now is the very first IPI. So over the course of the last month or so, the guys have been developing all of the trimming strategies necessary for our cyclic and collective heads. So they look very pretty in renders, but they're not the easiest things in the world to trim, and we've developed out the techniques to be able to trim these. We've developed the lighting, the backlighting for the decals. We've dealt with all of the perceived quality issues for the feel of the buttons that sit on the switch heads. The only thing that we've got left to do on this at the moment is to sort out the trigger functionality, and then we're well away with that. So really pleased with how these things are coming on. It feels great, and the trim quality is again far beyond what I hoped. Really, it's really delivered above and beyond on my expectations. So really pleased with that. The little inset pictures that you can see there are all of the components for the first two IPIs. First two instrument panels for HX50, so for the two machines for December. So they're all in stock now, waiting to be trimmed and then assembled onto the aircraft. So really pleased with how all that's coming together. If we talk briefly about the DigiCockpit, what we've got behind me at the moment is a second cabinet which is being used to essentially bench build the wiring looms, all of the hardware and all of the physical equipment that are going into the two machines at Christmas ahead of transferring it to the aircraft. So the DigiCockpit corner is a little bit of a mess at the moment because there's so much going on there, but we're currently just integrating all of the hardware, the software and the wiring looms to make all of that stuff work as soon as it goes into the aircraft. So really pleased with that. One area that we've been talking to customers but not publicly about for a little while now is our exterior lighting clusters. We want to make sure that HX50 is sort of distinctive and elegant and lives up to all of your expectations that you'd get from a premium automotive product, but also that it works really well as both a day and night VFR aircraft. So we were always very keen that the night lighting and the landing lighting that we provide is really powerful and safe for use in the widest variety of conditions that we can imagine. We're now well into prototyping all of the lighting clusters. These prototype units will be used to verify all of the optical performance of the lights, all of the sort of manufacturability of the lights, and they'll also be present on the two machines that we demonstrate in December. So what you can see in the figure here, you've got a landing light in the nose, you've got a split anti-collision beacon partly in the nose and partly in the tail to give full 360-degree coverage. We've got contributing landing lights on the wingtip that provide a wider beam, and then you've got your navigation lights located in the wingtips also. We've got prototypes of both these are crude rapid prototypes that develop out the electronic parts on the bench over there that I'll show you right now, and we're expecting to have the wingtip lights with us very shortly. Let's go and have a look at these things in action. So what you can see here is the inside portions, and none of this has been sort of finished with chrome coatings or any of that yet. This is purely rapid prototype material. So we've got the 3D Hill badge on the top of the unit. We've got a bright chrome Hill emblem, and that's what you'll see when you walk up to the aircraft. And then below the center, we've got the forward portion of the anti-collision light, and I'll demonstrate the rear version of that in a second. And then we've got the optics for the LED landing lights right here. So if I just pop those on for a second, then all of the electronic and optical design for these has been completed. I'll just knock them off center so I don't kill the camera. All of the heat sinks and the electronics are packaged within the module, and these things will literally light up anything that you want to. They're incredibly powerful. So we've got a little bit of tuning to do with those to get the spread and the level and intensity of those things right. But these things are working a treat. The finished versions of these with all the appropriate finishes and packaged into within the lenses are being built right now as I speak. So really excited to see those things come together. Our lighting production partners have done an absolutely incredible job. Let me just show you the tail light cluster. I'll just pop that down there for a second. So this is buried into the tip of the ducted fan. So you've got a chrome finishing piece around here. You've got two contributors to your rear navigation light, and then you've got your anti-collision beacon that fits right there. And this thing has got an incredible range of visibility. So if I just knock that on for a second, I'll just turn it away from Milan so it doesn't blind him. But that's all operational. We're using some proxy drivers at the moment rather than the correct airworthy drivers, because this is all about the optical performance. It's all about getting the manufacturing engineering of these clusters right, and then of course getting the heat rejection right for the various environments that these things will be operating in practice. So really pleased with how these things are coming on. We've got a little surprise for you with the strip lights that run down the side of the fuselage, and we should have the wingtip lights in this state within the next week or so. So really pleased with how the lighting hardware is coming together. In terms of the interior, it's been also a busy old week on the interior, a busy old month or so on the interior. We've been doing a lot of work on our crew seat. If you remember back to our last global meetup, we put a technology demonstrator on the stand. So this brought together the crashworthiness, the composite structures, the trimming essentials and structures, and all of the other elements that we need. What we're doing now is taking that to a new level with a Generation 2 crew seat. So this goes back much closer to our original design intent, brings all of those technologies together and delivers a really beautiful and comfortable seat. What you can see in the inset picture there is some of the underpinning structure that we're testing at the moment before it gets trimmed and finished off, and that work's going on right now with one of our partners. And then the other thing that we're working on at the moment is all of the interior surface of the aircraft obviously has to be trimmed, so that requires substrates. So we've been designing all of the clip-on substrates for trimming your pillars, your roof linings, your chin beams, and all of the other things that are required to be able to deliver that plush automotive grade interior that you all want for HX50. So really pleased with how that work's been coming on. It's really coming together. So I would ordinarily do a quick walk around at this point, but I'm conscious of time. I'll just quickly show you two things while we're here. In terms of the skid development, what we've got here is the last of the receptacles that will go into fuselage 7, and this is what the front skid connectors are attached to in the fuselage. This is how we get the loads into the fuselage. And then on the 3-axis at the moment, you can see that we're busily producing the first lower half of the gearbox casings for the 3 gearbox casings we're producing for December. So that's pretty much what we've been up to over the course of the last few weeks in terms of mechanical components. Let's talk briefly about some additional production facilities that we're developing. I mentioned while we were down at DC2 that the gantry mill has become somewhat problematic for us. Gantry mills are critical to composites because we need to make vast patterns, vast molds, and then we need to trim these large composite components, trim glazing, and that requires these great big CNC machines that can do that reliably and repeatably. These machines are different to the machines that we have here because they have to have extensive dust extraction and manage large amounts of material removal. Our gantry mill was bought secondhand during the pandemic, simply because you couldn't get anything at that time and we needed to progress. But the machine has become so unreliable now that it's costing us significant amounts of time in the program. So we've elected to purchase the first of the gantry mills that we'll use in production. So we've invested in a vast 8.5 metre by 5 metre by 2 metre working envelope gantry mill. This will be the machine that produces all of the production tools. It will produce all of the production patterns. It will trim all of your windows. It'll trim all of your doors. It'll do all of those operations, and it lands here in the UK in January this year. So from January, the kit that we need to produce all of these things for your aircraft will be with us and will be working. It has, of course, landed me with another slightly challenging problem, which is it is bigger than any of my facilities. So we're going to need some more space. So we'll get onto that in just a second. But the other thing that this thing does as well, this is the machine that produces your composite rotor blades as well. It produces those tools for the rotor blades that we go flying with. Let's give you a quick update on where we are with the production facility. As you were aware, we were due to be submitted to committee a little while ago. That was delayed. It was delayed again, and now the planning authorities are requesting that we do what they call an environmental impact assessment. They estimate that the timeline for this will be between 5 and 8 months. Given what we've seen so far, I think it'll be longer than that. So the development facility is now on the critical path, which means we have to consider our production continuity plan. That's what we're doing now. So our next step is essentially to take on a large rented space that will give us all of the room that we need to complete the development and then move seamlessly into production. There's plenty of these facilities available in our area. We're in negotiations with a number of facilities at the moment. We haven't yet decided on the exact site or size, but this will be done before the event in December. Okay, so there's some decisions to make, whether we split production and flying or whether we use multiple sites. All of those options are open and they make no difference to our ability to deliver. So we're getting on with this right now, and we're just making sure that we can stick as closely as possible to our declared timelines. So really pleased with how this is coming along. The other thing that this does, of course, do is it means we can take as long as we need to develop the HQ, and it also means we can consider sites at airports, which make the whole planning issue a lot easier as well. So what we've done here is, rather than being held ransom by a challenging environment, we've taken a very pragmatic sidestep, and now we move on at full speed. So with all of this fun stuff happening, sales have continued to roll in at quite a pace. We've now sold 765 X's, 178 C's, giving us a grand total of 943 aircraft. So just 57 to go until that magic 1,000 number. We're in 67 countries. There has never been a better time to join our community. So if you don't want to wait too long for your helicopter, come join us now. Thank you very much for listening to me, and I'm happy now to answer any questions that you may have. Thank you.
Fantastic update, Jason. Thank you very much. This one was a really packed one, and I really appreciate the final part that you shared about the production, because we have a lot of those questions coming out about, well, how you're going to be producing, when it's going to be producing, how is the factory, and that was very clear today, making it clear also that production is going to start as planned. So we're going to go with the questions. The first one, and right away, is from Lawrence. We've been receiving questions on the chat, and if you have questions, just put it in now, because they'll be in sequence. Misha and I will be taking turns. So the first one is from Lawrence. It says, for those of us older pilots Will the digital displays have the capacity to display key data and enlarge display for easy viewing?
Uh, it, so at the moment, the DigiCockpit is just being developed as a minimum viable product, as we say. So we're defining just the core features to make the thing work properly. Of course, with a digital environment, you've got the option to overlay as many themes as we want to, and to vary things like font size. The only challenge you've got with that is, unlike a car display, we cram a lot of information into the real estate. So there are some practical limits to how much you could expand the size of the fonts. But fundamentally, the fonts are being designed to be readable by anybody that can pass an aviation medical. So at the moment, if you look at some of the graphics that are out there, some of the fonts are a little bit small. We're cognizant of that. We're sorting that out. It's being mopped up as part of this UX redesign that we're doing at the moment. But fundamentally, if you can pass a medical, you'll be able to see it.
Okay, very good. Next question is coming from Michael, and it says, are there any updates on the camera systems? You had mentioned terrain avoidance and possible night vision.
There's no updates on that at the moment because we have a laser focus on just the core functionality. I've got to get this machine built, I've got to get it on test, and I've got to get it flying. Some of those additional features will follow a little bit later, as will a lot of the options that we get asked about repeatedly. At the moment, we have to focus on the fundamental flying bits and pieces of the helicopter. Get the structure right, get the drivetrain right, get the engine right, get the core elements of the DigiCockpit right, and go flying, and then get that approved. From that, we can build anything and everything else. While we're going through approvals and flight testing, the team will be doing just that. But right now, we have to stay really, really focused on the key deliverables.
Paul Ander has the following question. For long-range flight, will there be an option of a connection to a tank bladder from the back seat or a cargo to the fuel tank for extended range?
We haven't planned for that as yet, so that will inevitably come because everybody always wants to fly further and longer. But you have to remember, we've got a 5-hour fuel tank as standard, so you can fly for 5 hours at maximum continuous power in HX50, or for 5 hours at 140 knots. If you back that speed off a little bit, you can fly for longer. You can stay, your endurance improves, your best range improves, so you can go a bit further than that as well anyway. Fundamentally, there's no reason why there couldn't be a further extended tank, but it's not something we're doing at the moment. At the moment, you have a tank that's as big or bigger than anything you can get in any other helicopter. And so we've got to just get on and get that working. But yeah, I see no reason why we couldn't do it in the future.
Okay. Next question is about the whole skids versus wheels debate. And the question is about, is there a possibility if you chose one or the other, let's say you chose the skid version, you wanted to switch to wheels or vice versa, in the future, will there be the possibility that you could have the helicopter retrofitted and be able to swap it over from, let's say, skids to wheels?
So at the moment, there isn't a technical reason that exists today why that can't be done. So the airframes are identical. And no, there is a subtle difference. I think you have to work on the assumption it can't be done at the moment. We trim out very large portions of the underside of the fuselage to make the openings for the undercarriage bay. No, I think you'd probably have to assume you can't do that. You need to pick one or the other.
Okay.
Right on. Don is asking, any update on the pop-up floats?
Not yet. As I say, we have a strategy for how we're going to do the pop-out floats that's consistent for both wheels and skids. We haven't done anything else with it yet because we have to make a helicopter fly first.
Okay. And Lars is asking about the ground clearance for the skid version. Is there a high skid version? So if somebody needed extra clearance underneath?
There's no reason why we couldn't do that in the future. We haven't done that at the moment. The ground clearance on both the wheeled and the skids version is pretty good. It's about 350 millimeters off the top of my head. So I mean, it's not a lot different to what you get on most skidded helicopters anyway. So it's not something we're looking at right now. There isn't a reason why we couldn't do it in the future if it was popular and necessary.
Another question from Michael. We have the following. Will there be an HX80? Will the HX80 just be as a large HX50, or will it look different?
It will have the family DNA, so it will be a larger version of HC50, but it will be distinct in its own right. So that's all I can say at the moment. We haven't designed it, we haven't done anything other than paper studies yet. But yes, there will be one. Yes, it will look very similar. Yes, it will be bigger.
Okay, Christopher is asking, will there be any integrated online condition monitoring systems, i.e. vibration?
Yes. Yeah, so there's one of the key benefits of the way we operate, we call it active safety management, is that the environment that we create with the DigiCockpit and with the app will feed a great deal of data back to base about the health of the aircraft, how the aircraft's being used, that allows us to provide safety oversight on both the aircraft and its operational utilization as well. And that's all tied into the way we deliver our insurance program. So we'll be keeping an eye on the aircraft, we'll be trend monitoring, we'll be looking for any signs of distress, and we'll be also looking for any signs that the aircraft might be being used in a way that will inevitably lead to an accident, and that gives us the opportunity to intervene to protect those people in those conditions. So yes, there's a great deal of feedback from the machine to us for the benefit of everybody.
From Clint Pulver, and by the way, just a big shout out to Clint. He's doing an amazing job, a very unique thing that he's vlogging his experience of actually the development of the aircraft and his delivery later. He's doing a great job there. He interviewed Jason, was at the factory. Thank you, Clint, for that. And his question is, will the prototypes at the December event be able to demonstrate the blade folding capabilities and the process of that?
They have the means to do that. Yeah, they have the pins in, they have the blade roots in. We haven't planned to do that as part of the show, but I'll have a think about it and see what's possible. It's technically possible.
Okay. And Mar is asking a question for flight training purposes. He says he's starting training in January on the R22 and the R44. He's asking, should he be budgeting for a qualification in a turbine for the HX50? So to get comfortable with the HX50.
I wouldn't bother, to be quite honest. I think fly whatever's most convenient for you to fly at the moment. Helicopters are helicopters. The beauty of what we've done with the HX50 is it just makes flying easier. So you've got a benign, robust rotor system. You've got more power than you could ever dream of. You've got nice benign handling qualities and flight controls. You've got a really tightly governed engine. Operating the GT50 engine is simpler than operating a piston engine because of the FADEC system. So no, I wouldn't waste your money, to be honest. What I would suggest you do is go and get as much experience flying as you possibly can. So whatever makes that easiest is the best thing to do. We'll teach you how to fly turbines when your machine arrives.
There you go. David is asking, will there be a bleed air connection to operate any attachment that is hung on the cargo hook, such as a fire bucket or a bulk spreader?
There is bleed air off the engine. We haven't provisioned for anything specific as yet. So again, we have an engine with lots and lots of margin in it. We can do bleed air, but at the moment we haven't designed anything specific for that application.
Okay. Jamie's asking, what are the average use yearly running costs of the aircraft? So basically maintenance and any other major costs like that.
Do you want to take that, Misha? It's not changed from last time.
Yeah, totally. So if we're talking about maintenance, you're looking at, if you're flying the helicopter, about 100 hours per year. You're looking at one annual inspection per year. Now, there's going to be multiples of that annual or the 100. So when you get to 300 and 500 hours, there'll be multiples of that, which means it's a little bit more expanded of what that maintenance is actually going to look like. But for a conventional 100-hour or annual inspection, you'd be looking at an engineer working on that helicopter for about a day. So one engineer for a day in the U.S. with the U.S. Engineering costs, look at maybe around $1,000 for that inspection. So that would be an annual maintenance cost. So hopefully that answers that one.
All right, Giuliano from Canada is asking, we understand both the HS50 and the HC50 are designed for VFR flight and they don't have IFR certified. However, when equipped with 4-axis autopilot, will we be able to input waypoints and have it fly it? And how about inputting and flying precision approaches? If so, will we be doing it through the iPad or the digital cockpit?
So you can fly a route off an iPad. You can fly a 2-dimensional route off an iPad as standard in a HX50. You don't need the 4-axis for that, the 2-axis will do that. The 4-axis will launch with a limited set of capabilities and be expanded via software update as we develop more experience. The 4-axis system is still fundamentally a VFR autopilot. It just includes things like automatic speed control in auto rotation, full coordination of all the controls, being able to hold altitudes and speeds at the same time as each other. So we will expand that capability, but for the time being it will be a VFR based system. There will be an IFR variant that will follow, but not for a little while, because there's a significant amount of work to do to make that possible.
Okay, Carl is asking, the lower part of the airframe has cross members with notches in them instead of the holes. Is this a concern for strength or ground impact strength?
It's not a concern for strength, because the floor is bonded on the top of that, and it's the skin strength or the membrane strength of that floor that is important in those instances. Remember, you're not looking at finished airframes here. You're missing the bulkheads, the floor, and a couple of other bits and pieces that go in there.
Okay, the next question is, have you planned for remote door locking or even keyless ignition like in the car?
Yes, they do that.
Very nice.
So there's an ongoing debate in the company at the moment, because we'd all love to do it with the phones, but just because of the lifespan of these aircraft, it'll probably end up needing to be a key fob, just so that you can guarantee that protocols don't change faster than you can change the hardware in the aircraft, and it doesn't become a nuisance. Because these things will get to be 50 years old, and there's not many 50-year-old iPhones in service, are there? So yeah, we need to be a bit pragmatic about it, but there is central locking, and it is remote. It is keyless start as well.
Wonderful. Just make sure that key fob is very nicely designed, Jace, just like the
It
rest of the aircraft.
It will be. I won't show you the one we've got at the moment.
Okay. The next question is from Theory, and it says, will the GPS map be on the screen or just available on the tablet?
Just on the tablet. We don't want to go into mapping. I think we've addressed this in previous updates. Fundamentally, people like 4Flight and Oz Runways, SkyDemon, they do a great job of aviation mapping, and the various other apps around the world do an amazing job. They've got very large teams that are specialists in mapping. It doesn't make any sense for us to invest huge amounts of money developing and maintaining a mapping and obstacle database when there's guys out there that do it so well. So our system is designed to allow those technologies to continue to evolve, to always be able to accommodate the best of them, and then to keep the instrumentation in the aircraft and the systems in the aircraft limited to things that never change with time, like your primary flight instruments, your communication systems, and your basic flight controls. Everything else we do on the iPad.
Next question, will the displays in cockpit lighting accommodate NVD operations?
There isn't a plan for that. NVD, can you expand on NVD?
I think they probably meant NVG, so night vision goggle.
Yeah.
So NVG, so yes, we've been asked about this. Yes, we will do it. We're not doing it immediately. So at the moment, I've got to get the system to work. The changes that are needed to make NVG work properly are relatively subtle. We can accommodate them, but at the moment, we're just getting the basic system sorted.
Okay, next question is, are the buttons on the control sticks pre-programmable? Or reprogrammable,
no,
so I get using them for different purposes?
So No is the simple answer. At the moment, no, they're not, because they have very specific functions within the DigiCockpit.
Right. Next one is, I'm curious about the sound of the engine. As a turbine engine, will it have the same sound, so let's say, of an AC-130 or a Bell 407? Will the HC50 have proximity sensors similar to, but perhaps longer range to be that found in the car?
So the sound of the engine, I love the sound of the C250 series engines, so the Rolls-Royce engines, but that sound comes predominantly from those big diffusion tubes down the side of the engine and a big single can combustor at the back. If you go over to more modern engines, they don't sound quite as throaty, and we've developed a relatively modern engine, I'm afraid, so it'll sound much more like a Safran Arius, so like an EC120. Or a Bell 505 at startup. That's the sound you'll get. And the overall acoustic signature will be very similar to an EC120.
Okay. Have you given up on the LED lighting that highlight the windows? I
No.
believe this is the door strips.
The door strips, no. They're in.
Okay.
So my poor composite production team hate me at the moment because it took us a long while to find a solution that would make those signature lights work, and we found it, and we found an absolutely amazing organisation to work with on this. But it came quite late in the program, so we've had to modify a lot of tools to be able to put the volume in we need to be able to take that. So no, we've made the LED light strips and the animating features down there. We'll have the chrome strips that accommodate those within probably the next 10 days, and they will be in the aircraft in December. But I'm not going to tell you what they do.
That's a surprise.
Yeah.
December, yes. Very nice touch of a detail going to be seen here. Next one is, can you elaborate on how this is intended to operate, so the helicopter? Is it expected that the CAA will approve an amateur-built 5-place helicopter on a permit to fly in a reasonable time frame?
Yes. That was agreed back in 2017.
That's simple. That's right. That's right.
Yeah, very good.
Okay, can you give a little bit of that?
Okay,
That's actually a good point, Jason. Can you elaborate just a little bit of that historical decision,
Yeah. So
rationale
fundamentally,
back in 2017? Yes.
Yeah. So fundamentally, we get this question a lot. You can't have a permit to fly helicopter that's heavier than 700 or 750 kilos. That's not the case. You can get a permit to fly for anything. But what you have to do is use the correct basis for initial airworthiness approval. So if your helicopter happens to have 5 seats and a turbine engine and a max gross weight of 1,650 kilos, then that's a Part 27 helicopter. So what we agreed with the CAA is that we would show compliance with Part 27 in order that the aircraft was of a design and of a build quality to be justifiable as a permit to fly aircraft. You couldn't just take the requirements out of BCAR VLH, which is the UK kit helicopter standard, and try and build something this size. It's not appropriate. But all you've got to do is talk to the authorities, and that's what we did back in 2017. We agreed a rationale for that. And as with everything we do, there's a plan B and a plan C and a plan D if we do run into any problems. But fundamentally, this is an aircraft that complies 100% with the latest amendments of CS27 and CSE and the international counterparts to that. It meets every aeronautical standard necessary, so there is no way that they cannot approve it. If we demonstrate that properly with our design approval, our production approval, our flight test approval, and ultimately our maintenance approvals as well, it will be approved. And that's precisely what we're doing at the moment. It's why the CAA were here the other day.
Excellent. Very good. And Steve is asking the oil system, the gearbox and engines, are they separate like in the Bell 206, or are they more like the Bell B2, not the Bell, the Airbus B2?
So the engine gearboxes, so the speed reduction gearbox and the bevel box is part of the turbine engine system. So that's on a common oil system with the engine, but the main rotor gearbox is totally independent, and the tail rotor gearbox is just a splash lubricated, totally independent system as well.
Okay. All right, very good. So next one is a long one, but actually a very interesting one. So be ready for it, Jason.
Yeah,
As a
I'll pay
Moravella
attention.
has the, okay, as David is putting it, it's quite philosophical, but very interesting one. Actually, David owns serial number 346. Shout out to you, David. So here it goes. Jason, this is a more a philosophical question from a bird's eye view, but nevertheless very important. I'm sure you're familiar with the 80-20 principle, where generally 80% is accomplished with 20% of the effort, and that last 20 requires 80% effort to complete. Given the nonlinear nature of innovation of the innovative product development, have you considered this in your projected timeline? And if so, have you built a buffer so that the last 20% won't be rushed? Where do you see the HA50 currently at? Are we in the first 80 development? And how much of the 80 are we at? Sorry for these non-trivial questions, but to only have the best bird's eye view perspective across the program. I want to have that view. That's what he says. Thank you. So I think it was a quite interesting one, 80-20, 2080.
Yeah, so the problem with programs like this is that they're vast, and you can't plan for everything that you're going to encounter during a development program. So we can only plan with confidence up to the next major milestone. So at the moment we're planning to get these machines on stage for December, and we've got a good degree of confidence about that. And then we're planning for test flights beyond that, and we've got a good degree of confidence about that. But beyond that, when you start interacting with the aviation authorities in 67 different countries, when you're dealing with the scale up to production, it becomes less easy to predict with confidence how long all of those intricacies are going to take. So we're very focused on what the immediate goals are, and I'm confident that we can deliver our immediate goals in the timelines that we've outlined at the moment. As you've seen today, when external factors pose a threat to our timeline, we respond decisively. So, and that's applied across the whole program. So, with the technical development, then if we come across a major barrier in development, we won't just keep going and going and going. We'll just do something different so that we can deliver to a sensible timeline. But I'm confident that the stuff that really takes the time, the innovative stuff, the clean sheet of paper stuff, is essentially done. What we've got now is a very well developed design of the aircraft. We've got a very well developed manufacturing capability to produce all of the parts that we need to. Now we need to go through and implement the last details of what we need to do, go through a testing program to prove we've got everything right. There will be some loops there. It's inevitable that we'll find things on test that we need to fix, and then we go forward, approve it, and get it into production. So I'm fairly confident that we can deliver this in the timelines that we're stating, but all we'll do is tell the truth, as we have all the way through the program. As we hit problems, we'll report them, and we'll tell you what we're going to do about them.
Good. And Jerry's asking, would it be worth considering a PPF film for screen protection and scratch resistance?
Yeah, so yes, it will. I don't see any reason why not. Yes. Sorry, I thought you were talking about the windows for a moment, but you're not. You're talking about the paintwork. So yeah, I'm open to that. I've seen that applied to certain helicopters before. So yeah, I'm fine with that. In terms of the windows, obviously the polycarbonate windows are coated for scratch resistance, so it wouldn't make sense there.
Excellent. And before the next question, actually this is a good moment to just refer that this time after this AMA, we're going to do for the first time a sales presentation right away. This is because during the AMA we usually have a lot of questions about how can I order, what is the delivery time, what are the conditions, what are the current terms, So we're going to do actually a sales presentation that we do every single day, just 15 minutes past the hour. So in about a little bit over 45 minutes. So I'm going to ask just Rita to remind anybody through the chat if they want to register. Just have to put your name there so you receive the link to attend the Zoom presentation that takes about 30 minutes. So if you want to have all the details about how to order the aircraft, what are the terms currently available, you can do that by registering through the link that Rita is going to share on the chat. So next one is from Luca. How are you complying with the 51% rule for the EAB category in the US? 2 weeks, 80 hours seem a very low time to finish the build. 160 hours, all it is going to take to build the entire aircraft.
All of those regulations are subject to negotiation, and fundamentally you have to produce 51% of the eligible components, and the vast majority of the components in a helicopter are not eligible. And then what we've got here is a machine that's designed to be produced in a factory. So you have access to all of our production facilities and all of our tooling and all of our equipment and our production processes. So it's much quicker than trying to build a traditional aircraft that would have been built with minimal tools and equipment in your home workshop. So that's the fundamental difference. I mean, I often use the example that it takes 17 hours to put together a Bentley Continental GT. I think it's about 24 hours to put together a Range Rover. You know, so when these things have been designed properly, they can be produced really quickly, and that's the major difference. If it's designed to be produced in a factory, it can be done quickly. And remember, you're not expected to do gearboxes, you're not expected to do engines, you're not expected to do avionics, you're not expected to do paint or upholstery, you're not expected to do rotor systems. So there's a relatively limited scope of things that you need to do. Our flight controls are very simple because they're cable based. So it's a very efficient machine to assemble.
Good.
Unless you're doing it for the first time, and then it takes ages, as Dave will tell you.
Oh, excellent. It says, what is the max takeoff weight, max cruise speed, and max VTO speed?
The max takeoff weight is 1,650 kilos, and the max cruise speed is 140 knots, as declared at the moment. And VTO?
And do you have a max vertical takeoff? VTO, I believe that's vertical takeoff?
So maximum vertical climb speed.
I believe so, yeah.
That's that's dependent on a lot of things. It's dependent on weight and density, altitude. Ultimately, we'll put a limit on that of about certainly no more than 1,500 to 2,000 feet per minute. You've got power to go much faster than that, particularly when you're light. But the risk is if you go up vertically too fast and have an engine failure, the rotor RPM will droop dramatically because you'll continue to rise, then stop, then start to fall, and all the time you're doing that, your rotor RPM is dropping. So there's a practical limit on how fast we can allow you to climb vertically, irrespective of the performance. If I tell you that it'll climb vertically at over 500 feet per minute at max gross weight at 10,000 feet on an ISA plus 15 day, it will give you an idea of what it can do when it's low and light. And you really shouldn't be doing that.
All right, Jonathan has the following question. It is mentioned that there is a video surveillance system on the HAS50. Is that a black box type of setup, or is it the feed used for additional purposes?
The video surveillance is available via the app for people to use for their own social feeds and their own purposes as well. That data will then, as part of the agreement to use our insurance, will be used to, if it's needed to be used in an accident investigation, so we can understand exactly what's gone wrong. So it's very similar to the system that some of the helicopter companies are now fitting as standard. You have to understand that none of us live in isolation. We're all connected to each other and we all live in a community. If accidents happen, they don't just affect the families of the people involved, they affect everybody else that owns an aircraft, our business and the community at large. And so it's our responsibility as a modern manufacturer to use every instrument that we can to ensure that we keep the community as safe as possible. and all of that will be done in a. It won't ever be an intrusive big brother or anything like that. It's just intended to support people as they go through their learning journey of becoming a helicopter owner for the first time and building up their experience. And it's there for the benefit of everybody.
Okay, excellent. The next question is from one of our customers, Thomas. And prepare yourself, Jason, because you actually haven't had this type of question in quite a while. So it's going to be,
Okay.
what would happen, God forbid, if something happened to you, let's say tomorrow, and you were no longer available? What would happen with the company at that stage?
Well, you pair would keep selling helicopters and Mark could finish the job. So we're still going to need me for a little while yet. You know, there's still a lot of technical leadership that's required. The company needs a figurehead to navigate the approvals process and to get us into production. And so I'm going to be kind of important for a little while longer, and that is the reality of any company that starts from nothing. We have an amazing team now. So in fact, we have a spectacularly good team now. I'm privileged to have the people working with me that work with us. So in terms of delivering the technical outcomes, in terms of building aircraft, and in terms of sales, and in terms of the commercial management of the company, we have wonderfully capable people that can do that. But for a little while longer, it's going to need me to just keep pointing everybody in the right direction. So as with any startup, I'm kind of important at the moment, but every day that goes by I become more insignificant.
Okay, next question is about maintenance and what is the required tooling, infrastructure to maintain the HS50. So in any of those 67 countries they're going to be receiving HS50, what is the setup for maintenance of specifically tooling that will be required?
Nothing expensive is the easiest way to put it. At the moment I can't tell you because we haven't developed the maintenance program. But there's nothing out of the ordinary with this helicopter, and it's in our interest to make sure that these machines can be supported globally as inexpensively as possible. That's our business model. Our business model is to enable helicopter ownership. That requires you to enable helicopter flight training, helicopter maintenance and support all over the world. And so I wouldn't worry about that. We'll make sure that if there is any specific tooling required, then it's inexpensively available from us. Inexpensively and readily available from us.
Yeah, both important. Jonathan is asking, the 4-axis autopilot, is that something that you could add later on down the road once the aircraft is already built, if you change your mind?
You'd be missing a couple of actuators. So yes, technically you could, because it's the same flight controls and the way it's embedded. Yes, you could.
Okay, so an engineer would be able to have that as a kit that they can install.
Yeah.
Okay, next one will be from Martin. Will it have an hydraulic system redundancy? So is the hydraulic redundant or not?
It's redundant in the sense that you've got manual fly-through. So in the event that the hydraulics fail, you can continue to fly the helicopter, everything works, the sticks just get a little bit heavier. And we're developing the flight control system so as much of that is offset as is humanly possible. So it's relatively easy to fly for its size without hydraulics.
Good. And Sebastian is asking, the Hill digital display, does it have the possibility to be updated with new features, for example, autopilot or auto landing, or others when they become developed?
Yes, it's totally upgradable. So there's lots of headroom built into the hardware, and obviously software is infinitely variable. So we will continue to improve it as we get feedback from customers, and that will be all part of the maintenance subscription that we offer. So yes, it will continue to get better, and new features and feedback-based features will be rolled out as part of the support package.
Okay.
Andrew is asking for the soft field landings. Can bare paws be fitted to the wheels?
Yes. So there's a bare paw kit that is on the options list. We haven't designed it yet, but we've made provision in the undercarriage to take it. So it will come, and yes, it will be available, and yes, you'll be able to land in soft fields with that.
Very good. William's asking, how quickly can the dual controls be removed or refitted?
Very quickly. The collective and pedals are no different to what you're used to. In terms of the cyclic, the only difference to removing the one half of a T-bar cyclic that you might be familiar with is you have to reach underneath the panel to pull the pin out. But it's such a big nose area that it's not difficult to do. So about the same time as what you're used to.
Used to in a helicopter like a Robinson, for example, not used to in a Bell. Big difference.
used to in a Robinson. That's that's the sort of benchmark we've set ourselves.
Good.
Next one from Jamie. Is there going to be a backup standby instrument that you see on many panels with MFD and PFD setups? If so, is that going to be a standard instrument cutout or a custom unit?
You've got multiple layers of redundancy in the existing system. So each of the screens has an independent driver, and there's redundancy in where the data comes from for each of those drivers. So you've got independent computers that drive each screen, and then independent sources of data. So it's built in anyway. The second screen, if it's being used as an MFD, if you had a failure on the first screen, would be immediately switched over to being your primary flight instruments. And then of course, if you're flying with an iPad, you have all of your flight data there anyway to be able to get yourself safely back to the airport. So you've got 3 layers of redundancy there. Sorry, 2 layers of redundancy.
Yeah, excellent. And next question is
one other point on that. Just remember, it is a VFR helicopter. You fly it by looking out the window, and those displays only tell you, they only give you information, they don't control anything. So the haptic power management in HX50, you can feel when you hit 100% because the stick goes stiff. And in terms of the cyclic, when you sit in the machine, you'll see there's a mark on the center of the console and a mark on the stick, so you can locate a normal cruise attitude for typical CG position. So you can fly the machine without reference to those instruments relatively easily, and that will be part of the flight training program.
Good, that's really important.
That's right. There's a little bit of a confusion we have sometimes. Some clients are asking. Sometimes you get the impression it's almost an IFR aircraft, which is not, because of the digital cockpit that has so much, really a system that gives you extra layer of information to fly VFR, but no IFR. So that's a very important point. You get these systems; they're so well designed and easy to use that it's almost tempting to do IFR, but it's not as a VFR aircraft. That's a good point.
It's absolutely not an IFR aircraft. It's not designed for that. It doesn't have the features necessary to be an IFR aircraft at the moment. And that digital cockpit was designed to reduce pilot workload in inexperienced pilots. That's its purpose. And so it makes it easy to know where you are in terms of power, attitude, and in terms of your altitude and speed and your communication system, but that's it.
Yeah, and also important to note, I think that a lot of our customer base and our viewership as well are fixed wing pilots, so that's their background. They don't have helicopter experience, and so from a fixed wing background, things like having your airspeed are absolutely critical. If you lose that airspeed, you're going to stall the aircraft. In a helicopter, it's much different in the way that you fly. You fly a lot more based on visual cues. You're closer to the ground, so having those types of instruments are not as critical for your basic flight. So next question is from Luca. It's a crashworthiness question. But just before I ask the question, I just want to remind everybody, we are coming to the close of the Q&A session. We just have a few more questions here. So if you guys have anything else that you'd like to ask, you can definitely post that in the chat right now. And we'll ask those last few questions as we wrap up this session. And like Ruben mentioned earlier, him and I would love to see you guys in a presentation if you're interested in getting to know more information about the aircraft and about purchasing the aircraft. We're having one coming up in just over half an hour. And you actually can look on the chat as well. Rita's going to post a link to be able to register for that. And so you'll be able to have a look on there and see if you'd like to register for one of those presentations. But this question is from Luca. It's a crashworthiness question. It says that, does the carbon fiber cockpit behave to absorb impact energies, deform, shatter What about the seats? And what about the skids? Skids versus wheels. Do they spread? How does that work?
Yeah, so in the wheels, you've obviously got your oleos, you've got your gas springs that will absorb a certain amount of energy. They're basically designed to cushion normal landing loads, and the actual crashworthiness is provided by the carbon monocoque itself. The idea of the carbon monocoque is you have some energy absorption in the very lower part of it, and then the upper part of it is designed to keep the transmission and the engine out of the cabin and to provide a safe volume for the pilots and the occupants. Your seats are all crashworthy, so they stroke to absorb the downward and forward impact energy and protect your spine, so limiting the forces and decelerations that you see in your spinal column, so that even if you hit the ground without flaring at the bottom of an auto-rotation at night, you'd still have an impact that you should be able to walk away from. So that's the design criteria for the carbon. Carbon is an amazing material. It's incredibly strong, it's incredibly stiff, and if you design it correctly, it can absorb enormous amounts of energy. And that's exactly what the monocoque's designed to do. It's an extremely strong and capable airframe.
All right, could you please explain the working of the collective? The levers stick inside the cockpit. It looks like it moves forward and aft and not up and down. And also, where would the throttle be?
Yes, I can. Milan, are you around anywhere? And we'll show people. We've got a human factors demonstrator just at it's a bit rough and ready, but I can show you in there. Okay, right, I'm just going to get up and walk over to the demonstrator. Milan's going to come and join me in a second. Just shoot over my shoulder, Milan. So this is fuselage 4 that was a scrap fuselage. Basically, it didn't come out of the mold properly, but we fitted it out as a basic human factors demonstrator to work out how all of the flight controls work. If you just come over my shoulder for a second, Milan, the collective is designed to work with an armrest here, so it moves forwards and backwards like so. And the reason for that is when it's up in its cruise position here, your hand is conveniently located, so you've got access to the IPI screen, you've got access to the puck, and this fore and aft motion works compatibly with the armrest that we've got in the center of the airframe. Of course, if you were up and down, it wouldn't make any sense to have an armrest because your arm would always be going into the armrest. So it was designed like this to make it comfortable to have your arm on the armrest and just run the collective with the tips of your fingers. And then in terms of throttle control, with any FADEC controlled aircraft, you don't have a manual throttle on the grip. Essentially, you have a fly and an idle mode, so just a toggle switch that's on this space on the side of the collective here, where once the engine's running, you can click it from ground idle up to fly. And it's really as simple as that. So I really love this installation of the collective. I think it's far more comfortable. It's really compatible with touring, it's really compatible with VFR flying, and so yeah, it's a benefit. It's certainly not anything to be frightened of, and we're not the first people to do this. If you look at the collective installation in the Gazelle, that's far more upright. If you look at the old Bell 230 and 430 series, they did a very similar thing. The only other thing to say is on the co-pilot side, it is a conventional handbrake style collective implementation, and the reason for that is if you have your fore and aft cyclic on the co-pilot side, it gets in the way when you're trying to get in and out. So we've put a conventional one on the other side.
Okay, excellent. Thanks for the demonstration. That's nice to see. And the next question is from Bill. Will the ducted fan sound similar to a Gazelle or an MD600?
MD600's got a NOTAR, so it won't sound anything like that. It won't sound like a Gazelle. It will be a little bit quieter than a Gazelle. The first generation, well, not first generation, the early Fenestrons were quite noisy. It'll be a little bit quieter than that. The best proxy you've got is an EC120.
All right, the next question, the answer has already been addressed a couple of times in AMAs, but it's never bad to refer to it back again, so it clarifies. It is, judging from the high-tech digital cockpit, it would seem like this is a fly-by-wire cyclic in collective, or is it an hydraulic or mechanical?
It's well, it's almost completely conventional. So it is a mechanical flight control system. So you've got a cyclic that's essentially a post that goes down to the ground with some bell cranks and some levers that use flexible control cables, so push-pull cables that route up the nose of the aircraft onto the engine deck and straight into some bell cranks on the gearbox. We'll be demonstrating all of that at the event in Christmas. We've got a full drivetrain there so that you can see how the flight controls actually work. Same with the collective. That just moves that big seesaw bar I showed you up and down via some push-pull cables. So no, it's not fly-by-wire. We're not ready for that yet.
Okay. And next question is from Jim. Will lithium batteries be an option, or will they be standard for the aircraft?
They're standard.
Okay, very nice.
Done. Easy. Next one. Can you elaborate a little bit on the ground handling of the HC50? Both the wheeled and skid versions. Is it pushable by hand on a flat ground, for example? What about tow bar attachments?
Yep. So for the wheeled version, if you have the standard wheeled undercarriage, there's an attachment for a tow cart on the nose wheel, so you can tow it with a handle or you can tow it with a tow cart. If you have the HeliMove system, then there are motors available in the main landing gear wheels, and that allows you to control ground movement via electric motors using either the puck in the cockpit or your iPhone, a control interface on the Hill app. If you've gone for the skidded version, then there are some over-center wheels that fit into the skids as per other light helicopters, and again there'll be a jacking point that picks up on the structure that's provided for the nose undercarriage in the wheeled versions. So very, very similar to what you used to for the skidded version. Yes, you can push it, and there are plenty of structural positions where you're able to push the aircraft and pull it. So much the same. It's a big helicopter, and when it's full of fuel, it'll be quite heavy. So you'll need a tow cart if you're trying to push it around when it's full.
Okay. Kurt is asking, what kind of cost would your insurance program cost? And would it be based on a pilot in command total time, rotary, and total time on type? What hours are your build hours on type?
The best thing I can say about insurance at the moment is that it will be extremely competitive, because we see insurance as an enabler to sell more helicopters. We're not in the business of, we're not getting into insurance to make money, we're getting into insurance to make helicopters more affordable for people. So we will be essentially underwriting the whole value of the aircraft, allowing the insurers to essentially insure a lower hull value and so deliver cheaper, the people that underwrite our insurance deliver cheaper premiums. So I would expect the insurance to be less than you are paying on an equivalent value helicopter today. And in terms of how risk is evaluated, it'll be the same for us as for everybody else. But of course, we have the advantage of all of the telematics that go with the aircraft as well. So it gives us the ability to drop premiums lower based on how the machine's used.
From Gary, next question. If forced into a rotation, will the wheels come out automatically?
No. No, you need to deploy the wheels by choice, because you may choose to land with the wheels up, and you may want to keep the wheels up for as long as possible to reduce the drag on the aircraft and improve your glide range. So it's a pilot choice. If you're flying at a sensible altitude, you've got plenty of time to get the wheels down.
Wonderful. And Cecile is asking, talk us through the startup procedures. Is it auto startup via instrumentation using software, or is it still traditional buttons and lights and instrumentation?
Master battery on, avionics on, start. And then when you're ready to take off, you click from fly to idle, and away you go. That's basically it. There'll be a few other steps in the POH, but that's all you need to do essentially. It's very simple, and the FADEC does the startup for you.
Wonderful.
Fantastic. So we are reaching the last question, and before that, actually, Jason, well, not before, after this question, I'm just going to ask you if you could end to making it very clear and just overview what are the plans of the next production facility? Because we had a couple of questions about that, and because it was addressed during the presentation, they were not asked directly. But I'd like you just to, if you could overview that, and that will be a great way to finish. If you could give us a good overview, what are the plans, what's coming, great surprises here, fantastic plans for 2024. As you said, there's some machines that don't fit exactly the current facilities, and what's moving that so quickly. So before that, just before that, I'm just going to ask this last question. If then you can answer this one, and then you can answer the last one. You can close the session after that. So next one will be, what will be the max all-up weight and external load configuration? That will be the last question, and then you can finish off and finish your way. Go ahead.
So at the moment, we're declaring that the max all-up weight for external load will be 1,800 kilos. I suspect we're going to be able to push it a little bit further than that, subject to engine power limitations. You may have noticed from some of the images we posted recently that we've added a little bit of blade area to the main rotor as part of the final design tweak to the aerodynamic design, and that's to protect the really high speed performance at hot and high conditions. And that gives us a significant improvement in lift capability at lower density altitudes. So expect 1,800 kilos. It may go up a little bit from that once we've proven it on flight test. In terms of the production facility, essentially I have a machine coming in January that would fill DC1 if there was nothing else in it, and so we need a significantly bigger facility. Now DC2 and DC3 are just rented and they're on short-term leases. So what we will do now, while we're facing uncertainty about the time it will take to get the sort of purchased Global HQ built, we will rent a facility in the local area that is big enough to complete all the development and to go into production. At the moment, we're working out exactly what size that needs to be. I expect it's going to be somewhere in the region of 100 to 150,000 square feet, something like that, which would combine the DCs we have at the moment and give us the ability to honour stated production volumes. It'll be a very busy facility, but we'd be able to honour that while the full HQ is being built. So it's the path of least risk, it's the path of least resistance, and it's the fastest way to get us into production. But all of that is live. At the moment, I'm totally swamped with getting these aircraft delivered for December, and I've got a team of people looking at building options for us in the local area to be able to do that. But expect us to homogenize to bring all of the existing facilities together and to go the next step up in size. And I would also note that although some manufacturers have very, very large facilities now, those large facilities are substantially engaged with supporting very large fleets. And if you look back at certain manufacturers, they were able to produce 400 helicopters a year out of 50,000 square feet at one point, and 800 helicopters a year out of 260,000 square feet. So we're choosing very carefully what the next step will be. But all of this will become clear as we complete the deal between now and the end of the year.
All right, Nish, you gotta go ahead and just
absolutely.
It's
yeah, we're just exactly. We're just closing off this this session now. Jason, it was a wonderful one. Thank you for taking your time. I know you're incredibly busy, so these AMAs always take up a substantial amount of your time to get prepared for them and so forth. So just want to really thank you for that. I know everybody that attends these presentations, usually well over 2,000 people, they really appreciate it as well. And we look forward to the next one. We're actually going to have one more in November. We're going to be announcing that soon for the date for that one. We're going to have one more of these AMA sessions in November before the event in December. So we're really excited to show you some pretty groundbreaking things on that one, I think, as well, which is going to be really fun to see. And then for anybody that's registered for the December event on the 6th and the 7th, the 6th is going to be for clients only. And so if you're a client, we look forward to meeting you and seeing you again on that 6th of December. And then the 7th is actually going to be an open house. So for anybody that is wanting to come and see the aircraft, actually be able to sit inside of it and interact with the aircraft a little bit, ask the team and Jason some questions and so forth, the 7th is going to be open for that time as well. So we look forward to seeing you guys all at that session. and also on the next AMA as well. So thanks again, Jason, for your time, and have a great day and a good evening for everybody.
Thanks, Ruben. Thanks, Misha, and thanks everybody for tuning in. We'll speak to you next time.